Welcome back to Dish and DAS Administration 1, FR 100. My name is David, and I will be your instructor for this learning module. In Module 8, you will learn about persistent frame accounts, starting with the question, what is a persistent desktop? We will look at managing capacity for persistent accounts, and finally, I will conclude with a demonstration of how to manage and assign persistent desktops to your end users. Earlier in this course, in Module 3 to be specific, I explained the concept of non-persistent or stateless desktops. In this type, any changes made by the user are wiped out at the end of the session. The non-persistent backing VM is short-lived, with each session creating a new VM from the sandbox image on startup. Contrary to this, persistent desktops are stateful, desktop-only instances which are individually assigned to users. Users can be given administrative control over their own desktop. They can install and manage their own unique application sets and settings in their own persistent environment. Account administrators can still monitor usage and basic session activity through the account dashboard. To further compare the two types, a non-persistent VM can provision from one or more instance types. This means the same sandbox image can be used to serve users with different resource or application launchpads. Also, the max capacity can be set uniquely for each production pool, allowing you to dynamically scale. A persistent desktop is initially backed by a single instance type at creation. The instance type can be changed for an individual persistent desktop after it has been assigned to a user, but there is not a concept of multiple production pools or launchpads. It is not to say that one type is better than another. They serve different use cases and thus have different functionality. Publishing a persistent pool is much different on the back end. Instead of creating a shadow pool after the administrator clicks Publish, an unassigned shadow VM is created from the sandbox clone. This VM is then made available for the next user and will be assigned to them when they make a request for a desktop. This is now that user's desktop until it is unassigned by an administrator. When creating a persistent frame account, follow the same workflow as before, but the key difference is to ensure the persistent desktop radio selection is toggled on. You won't see any differences during the Create wizard. But later, the management workflow and settings will be tailored for the persistent desktop type. Setting capacity allows you to define the maximum number of desktops that can be assigned. This number can be increased as needed. When decreasing, it should be noted that any already assigned desktops will not be terminated. An additional step must be taken to unassign a persistent desktop from a user first. If you wish to keep instances running, you can set when and for how long the persistent desktop VMs stay powered up. This can be useful for instant on type access to provide a better experience for the end user. Note, this can increase consumption of the infrastructure, which may incur costs or cause additional server load depending on the cloud provider. When increasing the max capacity of a persistent account, additional desktops are created using the last published sandbox image state when cloning. In addition, the platform will not create new VMs until they are required to be assigned to a user. This is different than the publish operation of non-persistent in that already provisioned VMs will not be affected. Because persistent desktops are stateful, the delta of changes from the sandbox image needs to be kept and available for the assigned user. This is achieved by linking a storage volume to the desktop. Because these volumes may contain important data, applications, and configuration settings, the DishN platform supports creation of backups. Manual backups of volumes may be retained up to a defined limit. Similarly, a scheduled backup can also be configured with a defined retention limit. Volumes can be set to auto-grow as the user consumes more disk space. Because storage often has a cost associated with it, most administrators will want to control the amount of growth by setting a limit. I will now demonstrate managing and assigning persistent desktops. First, a summary of this frame account shows we are using an Azure cloud provider with a Windows 11 VM. The sandbox instance type is a Pro 28GB with 8 CPU cores with an AMD GPU and a 200GB disk. Authentication is configured to use SAML2 with Entra ID. The max capacity is currently set to a maximum of 1, which is fine for the purposes of this demonstration. I will leave the default setting of Basic for the Keep Instances Running selector. I want to control costs on the cloud so the VMs will not remain on. Clicking on the VMs menu is where we visualize the created desktops and set the user assignments. Take notice of the VM type. You will see labels for both Sandbox and Persistent Desktop. Notice the user assignment and instance type. With persistent pools, you can modify an assigned desktop's instance type to be different from the Sandbox. This can be done on a per-user basis if desired. To do so, click the three-dot menu on the right of the VM and select Change Instance Type. Depending on the cloud provider, you will see a list of supported and available virtual hardware specifications to select from. Remember that each instance type will have unique sizing and costs associated with it. Click Save to make the change and the platform will reconfigure the desktop's backing VM. To unassign or reassign a desktop to another user, click the three-dot menu again. To unassign, click the menu item and confirm when prompted. When reassigning, the list of available users is retrieved from the identity provider configuration for this account. Once the new user has been selected, click Save. It is important to remember that each persistent desktop has an assigned volume where the applications and data are kept. The starting size of the volume is based on the size defined in the sandbox. To take a manual backup, click the three-dot menu and select Backup. Click Create and the backup will be taken. To increase the size of a volume, click the three-dot menu and select Increase Disk Size. Adjust the size and click Save. You can control backup settings and configure Schedule Backups by clicking the Backups submenu at the top of the panel, then the three dots menu on the right of this pane, then click Settings. To define a schedule, enable the feature, set the time, time zone, backup interval, and retention policy. For this example, I will adjust it to daily using a 7-day interval. This has then effect of running weekly and only retaining 3 weeks of backups. Once saved, this will now apply to all volumes in this pool. And that's it. Persistent pools may require a little more administrative overhead to manage, but offers more control over the desktop. A new feature available is the ability to suspend or hibernate a persistent desktop. This is similar to lifting your laptop lid. All of your application windows and previous activity is resumed from when you closed it. This is contrary to having to start from a fresh boot of a machine where you must log in and launch applications each time you start a session. It should be noted, not all cloud providers or instance types will support this capability. The suspend session action is available from the terminal bar to manually call for a suspend. Also, if the suspend feature is set up in session settings, an idle timeout can also trigger the action. Suspend will not be triggered if the user chooses to close or quit their session, and the VM will be powered off instead. Let's review what you've learned in Module 8. Persistent desktops are stateful, desktop instances which are individually assigned to users. The instance type of an individual persistent desktop can be changed after the desktop is assigned to a user. The workflow for publishing and managing persistent is different from non-persistent type pools. Second, the maximum number of desktops can be increased after creation. New desktops are created as needed and will use the last published sandbox image. Lastly, I demonstrated managing and assigning persistent desktops. This concludes the lesson module. Be sure to check out the other videos in the series that make up the full course. Thanks so much for watching.